Out here in the darkness between thoughts and sleep, we find ourselves asking the same question humanity has whispered for generations. It's a simple question, really, almost childlike in its honesty, and yet it contains within it one of the deepest mysteries we've ever encountered. Where is everybody? That's all it was. 3 words, spoken over lunch by a physicist named Enrico Fermi, and I'm 50. He was talking with colleagues, probably over something ordinary. Coffee, sandwiches, the kind of meal you barely remember. But that question has echoed through the decades since. It's still echoing now, as you and I sit together in this quiet moment. You see, Fermi understood something profound. He understood the sheer scale of what surrounds us. And when you truly grasp that scale, when you let yourself feel how vast the universe actually is, the silence becomes strange, unsettling even, but also, in its own way, beautiful. We're floating on a small blue planet, orbiting an ordinary star in an unremarkable corner of a galaxy that contains hundreds of billions of other stars. And that galaxy is just one of hundreds of billions of galaxies. The numbers stop making sense after a while. They become more like poetry than mathematics. And with all those stars, all those galaxies, all those incomprehensible chances for life to emerge somewhere, anywhere, why do we seem to be alone? This is what we call the Fermi Paradox. Not a paradox in the formal sense, not a logical contradiction, but a paradox of expectation. The math suggests the universe should be teeming with civilizations, ancient ones, wise ones. Civilizations millions of years older than ours, with technologies we can't even imagine. And yet, when we look up, when we listen with our most sensitive instruments, we hear nothing, just silence. The same silence you might be hearing right now, wherever you are. The silence of a room at night, the silence between heartbeats. Fermi's question wasn't meant to have an easy answer. It was meant to open a door. And once you walk through that door, once you really start wondering where everybody is, you find yourself in a place of profound mystery, a place where every possible answer tells us something haunting about the universe, about life, about our own brief moment of consciousness in the cosmic dark. We're going to spend some time in that mystery together, not to solve it, we may never solve it, but to explore it gently, to turn it over in our minds the way you might turn over a smooth stone in your hand, feeling its weight, its coolness, wondering about all the forces that shaped it. There's no hurry. The universe has been settled on it for billions of years. It can wait a little longer while we think. Let's talk about numbers for a moment, not in the cold clinical way of a textbook, but the way you might count stars on a clear night, knowing you'll never finish, but finding comfort in the attempt. Our galaxy, the Milky Way, contains somewhere between 100 and 400 billion stars. The estimates vary, and honestly, when numbers get that large, the precision hardly matters. What matters is the feeling of it. Imagine trying to count them, 1 per second. You'd be counting for thousands of years. Lifetimes would pass. Civilizations would rise and fall, and you'd still be counting. And around those stars were planets. So many planets. We used to wonder if planets were rare. We used to think maybe our solar system was special, unusual, a cosmic accident. But we've been watching now. We've been looking carefully at distant stars, measuring the tiny wobbles in their light, the minute dips in their brightness as worlds pass in front of them. And what we found is extraordinary in its ordinariness. Planets are everywhere. Nearly every star we look at has them. Small ones, large ones, hot ones frozen in eternal ice. The galaxy is crowded with worlds. Current estimates suggest there might be more planets than stars in our galaxy alone. Trillions of them, trillions of chances. Now, not all of those planets are like Earth. Most aren't. Most are too hot or too cold, too large or too small, orbiting too close to their stars or too far away. But even when we narrow it down, even when we look only for planets in what we call the habitable zone, that Goldilocks region where water might be liquid, where life as we understand it might take hold, the numbers remain staggering. There could be tens of billion whole of Earth-like planets in our galaxy alone. Tens of billions. Let that settle for a moment. Breathe with it. We're not talking about the entire universe now, just our neighbourhood. Just this one spiral of stars among countless others. If even a tiny fraction of those worlds developed life. If even a microscopic percentage of those living worlds developed intelligent life. If even the smallest number of those intelligent species survived long enough to reach out across the stars, we should see them, we should hear them. The galaxy should be alive with signals, with evidence, with the unmistakable signs of others asking the same questions we're asking. This is what Fermi understood over that lunch table in 1950. The probability isn't just on the side of alien life existing, it's overwhelming. The math argues for a universe teeming with consciousness, with civilizations, with others who have looked up at their own night skies and wondered if they're alone. And yet, that silence again, that profound, puzzling quiet. It's not that the numbers are wrong, the math is sound, the probability is real, but something is happening or not happening that we don't understand yet. Some piece of this cosmic equation is missing or different than we assume. This is the weight of the Fermi Paradox. Not just that we haven't found anyone yet, but that according to everything we know about the universe, we really should have by now. The numbers say we shouldn't be alone. Where is everybody? We'll explore some answers together. Gently, one possibility at a time. We've been listening. For more than 60 years now, we've been listening. Turning our radio telescopes toward the stars, scanning frequencies, searching for patterns in the cosmic static. It's patient work, quiet work. The kind of task that requires a particular type of hope. The kind that doesn't demand immediate answers. The search began in 1960 with a project called OSMA, a single radio telescope pointed at two nearby stars listening for 8 hours a day over 4 months. They heard nothing but natural radio noise, the ordinary whisper of the universe going about its business. But something had begun, a conversation, even if one-sided. We had started reaching out across the dark. Since then, the search has grown. SETI, the search for extraastronomical intelligence, has become a dedicated field of study. Multiple telescopes, scanning millions of frequency channels, listening to thousands of stars. The Allen Telescope Array in California, the Green Bank Telescope in West Virginia, observatories around the world, all tuned to the same question. Is anyone out there? And what have we heard? Pulsars, those cosmic lighthouses spinning in the void. Quasars, the brilliant hearts of distant galaxies. The background radiation left over from the universe's birth. We've heard all the natural phenomena of space, its groans and whispers, its electromagnetic symphony. But we haven't heard anyone calling. There was one moment, one tantalizing possibility. In 1977, a strong narrowband radio signal was detected from the direction of Sagittarius. It lasted 72 seconds. The astronomer on duty that night was so surprised he wrote, "Wow!" in the margin of the computer printout. We call it the WOW signal now, and we've never heard it again, despite returning to that same patch of sky, listening with better equipment, hoping it might repeat. Maybe it was a satellite, maybe some terrestrial interference, maybe something we'll never understand. The universe doesn't always explain itself. This is the texture of the great silence, not absence exactly, but a lack of the specific thing we're hoping to find. We're listening for language in the wind and hearing only wind. We're searching for intention in the stars and finding only the clockwork of physics. You might think this would discourage us, that after decades of silence we'd give up, turn our telescopes to other questions. But we haven't. we keep listening because the universe is unimaginably vast, and we've only sampled the tiniest fraction of it. We've barely skimmed the surface of the possible. Imagine trying to find a friend in an enormous city by listening for their voice, but you can only listen to one street corner at a time for a few minutes each, and you don't know which city they're in or what language they speak. That's something like what we're attempting. The odds of success on any given day are vanishingly small, and yet the listening continues, not because we're certain of success, but because the question matters, because even searching tells us something about who we are, a species that looks up and wonders, that hopes for connection, that refuses to accept loneliness as the final answer. The silence doesn't mean no one is there. It might mean we're listening in the wrong way, at the wrong time, on the wrong frequencies. It might mean they're there, but quiet. It might mean we simply haven't listened long enough yet. So we continue, patient, hopeful, listening to the great silence, waiting for it to break. There's a kind of loneliness built into the architecture of space itself. Not an emotional loneliness, something deeper than that, a structural isolation written into the very fabric of the cosmos. Let's talk about distance. When we say the nearest star to our sun is about 4 light years away, that number might not sound too dramatic at first. 4 years. You've lived through spans of 4 years. They pass. But a light year isn't a measure of time in the way we experience it. It's a measure of distance so vast we had to use the fastest thing in the universe just to describe it. Light travels at 186,000 miles per second, every second, without pause, without tiring. And it takes that light 4 years to cross the space between us and Proxima Centauri, our nearest stellar neighbour. 4 years at the speed of light. With our current technology, the fastest spacecraft we've ever built, that same journey would take about 80,000 years. Longer than recorded human history, longer than our species has been using written language. You would launch a probe, and 4,000 generations later, your distant descendants might receive its first data from another star. And that's the closest one. Most stars in our galaxy are thousands or tens of thousands of light years away. The galaxy itself is about 100,000 light years across. And those other galaxies we mentioned, the hundreds of billions of them. The nearest significant galaxy to ours, Andromeda, is 2.5 million light years distant. Can you feel it? That crushing weight of emptiness between things? This is one possible answer to Fermi's question. Perhaps they're out there. Perhaps civilizations have risen on 1,000 worlds, 1,000,000 worlds. Perhaps they're thriving right now, this very moment, looking up at their own night skies and wondering the same things we're wondering. But the spaces between us are so monumentally vast that we might as well be in separate universes. Even communication becomes almost impossible across such distances. Imagine sending a message to a civilization 10,000 light years away. Your radio signal travelling at the speed of light would take 10,000 years to reach them. If they heard it and responded immediately, their answer would take another 10,000 years to return to Earth, 20,000 years for the single exchange of hello. Civilizations might rise and fall in that time. Languages would be born and die. The people who sent the original message would be ancient history before any reply arrived. Maybe the species itself would be gone, leaving the returning signal to echo through empty halls, unanswered. So perhaps the great silence isn't rejection or absence. Perhaps it's simply distance. The universe has built moats around its islands of life so wide that crossing them may be beyond anyone's ability. Not because we lack intelligence or determination, but because physics itself says no. There's something almost peaceful about this possibility, isn't there? If we're alone because we simply can't reach each other, then the loneliness isn't a failure. It's not that no one wants to talk or that we're not worth finding. It's just the way the universe is built. Vast beyond comprehension, beautiful in its emptiness, full of life perhaps, but each spark separated from the others by gulfs of space-time too wide to bridge. We might never meet our cosmic neighbours. We might spend our entire existence as a species knowing, on some level, that others are out there somewhere, but unable to ever touch, to ever truly connect. And still we are here, still conscious, still looking up. That might have to be enough. Here's a thought that might change how you feel about our place in the cosmos. What if we're not late to the party? What if we're early? The universe is 13.8 billion years old. That's an almost incomprehensible span of time. Civilizations could have risen and fallen countless times in that vast duration. Ancient empires of the stars, millions of years old, should be everywhere by now, or so we'd think. But let's consider something else. Let's think about when life becomes possible. In the very beginning, in those first few 100 million years after the Big Bang, the universe was too hot, too chaotic for anything like life. No planets yet, no stable stars, just hydrogen and helium swirling in the dark, slowly coalescing under gravity's patient pull. The first stars were massive, short-lived things. They burned brilliantly and died quickly, exploding as supernovae. And in those explosions, something crucial happened. They forged heavier elements, carbon, oxygen, nitrogen, iron, all the building blocks of planets, of life. It took generations of stars living and dying to seed the universe with the materials needed for worlds like ours, for chemistry complex enough to become biology. Earth formed about 4.5 billion years ago. Life appeared relatively quickly after that, maybe within a few 100 million years. But Earth couldn't have formed much earlier than it did. The universe needed time to create the ingredients first. So here we are, roughly 13.8 billion years into the universe's story. And really genuinely, we might be among the first. Think about what that means for a moment. There may have been a few civilizations before us, perhaps even many. But the great flourishing of life and intelligence across the cosmos, that might still be ahead. The universe might be in its early spring, with most of its life yet to bloom. We could be the pioneers, the first ones to look up and ask these questions, the first to reach out across the dark wondering if anyone else is there yet. There's something both humbling and profound about this possibility. We often imagine ourselves as latecomers to a cosmos already filled with ancient, wise civilizations. We picture ourselves as children in a universe of elders. But perhaps we're the elders. Perhaps we're the first ones to wake up in the vast house and wonder who else will eventually arrive. If this is true, it comes with a weight of responsibility we're only beginning to understand. The choices we make now, how we treat our planet, whether we destroy ourselves or learn to survive our own technologies, whether we eventually venture out to other worlds, these choices might echo across billions of years. We might be setting the template for what intelligent life becomes in this universe. And if we fail, if we destroy ourselves before we ever leave this small blue world, then perhaps the universe will have to wait another billion years for the next species to arise, to ask these questions, to reach out across the silence. But if we succeed, if we learn to survive, to grow, to eventually spread among the stars, then billions of years from now, when the universe is truly ancient and the night sky is crowded with civilizations, they might look back at us. They might study our time. They might know us as the early ones, the first voices in the dark. We don't know if this is true, of course. We're speculating, wondering, feeling our way through possibilities. But it's a real possibility, a scientific one, supported by our understanding of cosmic evolution. We might not be alone because we're special or chosen. We might be alone because we're first. And there's a strange kind of hope in that. Tab to section 6. Perhaps they lived and vanished. There's another possibility we need to sit with, though it's a quieter one, a sadder one perhaps. What if they were here? Not here on Earth, but out there, among the stars. What if civilizations rose, thrived, built wonders we can't imagine, and then fell subordinate? What if the universe has been full of voices, but they've broken faded before we ever learned to listen? Time is long, unimaginably long, and civilizations, even the greatest ones, might be brief candles in that darkness. Think about our own history, the empires we remember, Rome, Egypt, the dynasties of China. They felt eternal to the people living within them. Each generation assumed the world they knew would continue, that their cities would stand forever. And for a while they did stand, centuries, even millennia. But then they changed, transformed, fell, not always through violence or catastrophe. Sometimes they simply faded, evolved into something else. The people didn't disappear, but the civilization, that particular arrangement of culture and power and knowledge, it became something different. Or it ended. Now imagine this pattern playing out across the cosmos. A species develops technology, reaches toward the stars, perhaps even achieves interstellar travel. They build, they transmit, they leave their mark on their corner of the galaxy. But how long does it last? 1,000 years? 10,000? 1,000,000? Even 1,000,000 years? An inconceivable span to us is just a moment in cosmic time. Less than 1% of 1% of the universe's current age. If a civilization existed 2 billion years ago and transmitted radio signals for 10,000 years before falling silent, we would never know. Their signals have long since dispersed into the background noise of space. Their ruins, if any remain, are too distant for us to see. They might as well have never existed. The universe could be full of ghosts. Echoes of species who asked the same questions we're asking, who looked up and wondered, who maybe even found each other briefly before the long silence claimed them too. This isn't a comfortable thought. But there's something almost gentle in it too, if we let ourselves feel it fully. Nothing lasts forever. Not stars, not planets, not species. The universe is a place of constant transformation. Things arise, flourish, and pass away. This is the nature of existence, not a tragedy, but simply the way things are. Maybe civilizations are like flowers. Each one blooms in its time, beautiful and unique, adding something irreplaceable to the garden of the cosmos. And then, in their season, they fade. Not because they failed necessarily, not because they did something wrong, but because that's what living things do. They have their moment, and then they make way for whatever comes next. If this is true, if the galaxy has seen countless civilizations rise and fall, then we're walking through a graveyard we can't see. Ancient ruins on worlds we'll never visit. Technologies rusted away to dust. Questions asked and answered and then forgotten as the species who asked them became fossils, or less than fossils. Scattered atoms returned to the cosmic cycle. But we're here now, right now in this moment. Our candle is lit, our brief time to wonder and build and reach out is happening. And maybe that's what matters, not whether we last forever, but that we were here at all. That consciousness arose in this particular corner of space and time, that we got to ask these questions. Perhaps the universe is richer for every voice that speaks, even if each voice eventually falls silent. We were here, we wondered, we looked up. For now, that's enough. Now we come to a possibility that feels different from the others, a little darker perhaps, but worth considering as we sit here together in the quiet. What if the silence is intentional? What if they're out there, but they've chosen not to speak? There's a thought experiment that explores this idea. It's called the dark forest hypothesis, and it asks us to imagine the galaxy not as an empty wilderness waiting to be explored, but as a dark forest at night. Picture yourself walking through that forest. You can't see far in any direction. You don't know who else might be out here with you or what their intentions are. Every now and then you hear a sound, a branch snapping leaves rustling, but you can't tell if it's friend or predator. In that forest, what's the safest strategy? Silence, stillness, revealing nothing about where you are or what you're capable of. Because the moment you call out, the moment you light a fire or make noise, you've announced yourself to everything else in the darkness, and you have no way of knowing what might be listening. This is the uncomfortable logic of the dark forest. Perhaps advanced civilizations have learned through experience or wisdom or hard-won caution that broadcasting your existence across the galaxy is dangerous. That the universe might contain others who don't approach first contact with curiosity and kindness, but with something else. Competition, aggression, fear. So they hide. They keep their electromagnetic emissions to a minimum. They don't send out grand messages or powerful beacons. They watch, they listen, but they don't speak. And if this is true, then our own behaviour, our decades of radio and television broadcast leaking into space, our deliberate messages to the stars might seem incredibly naive to them, like a child shouting in the dark forest, unaware of the risks. It's a sobering thought, almost frightening if you let it be. But let's sit with it a little longer. Let's turn it over and see what else it might tell us. If civilizations are hiding, it means they exist. The silence isn't absence, it's caution. The galaxy might be full of watchful eyes, societies that have survived long enough to learn the value of discretion. That's almost comforting in its own way, isn't it? The idea that wisdom and survival go hand in hand. And perhaps they're not hiding from everyone, perhaps they're selective. Maybe advanced civilizations do communicate with each other, but only once they have observed a newcomer long enough to assess whether they're safe. Maybe there's a galactic community out there, and we're simply too young, too unpredictable, too dangerous to ourselves and others to be invited in yet. We're still a species that struggles with violence, with tribalism, with short-term thinking. We haven't even managed to live peacefully among ourselves, let alone proven we could handle contact with a completely alien intelligence. Maybe the others are waiting, watching, hoping we'll grow up a little before they say hello. There's another possibility too, one that's less about fear and more about respect. Maybe silence is simply the universal protocol. Maybe civilizations who reach a certain level of advancement understand something we don't yet, that the cosmos is healthier, safer, more diverse when each species develops on its own terms without interference. That contact, however well-intentioned, can disrupt or destroy younger civilizations, so they wait. They give us space to grow, to make our own mistakes, to find our own path. The silence isn't hostile, it's patient. We don't know which, if any, of these explanations is true. Maybe the dark forest is real and we've been dangerously naive. Maybe it's not, there's nothing to fear in speaking. But for now, we're still calling out into the darkness, still hoping someone will answer. Let's talk about luck for a moment, about the extraordinary chain of accidents that had to happen for you to be here, breathing, listening, thinking these thoughts with me. You exist because a specific sperm met a specific egg. Already the odds are millions to one, but go back further, your parents had to meet, their parents had to meet. Go back 100 generations, 1,000, and any single change, any different choice, any alternate path, and you wouldn't be here. Someone else might be, but not you, not exactly you. Now expand that backward to the origin of life itself. This is what scientists call the Great Filter. It's a concept that tries to explain the Fermi Paradox by suggesting that somewhere in the journey from non-life to spacefaring civilization, there's a step or several steps so improbable, so difficult that almost no one makes it through. Maybe we've already passed through the filter, or maybe it's still ahead of us. Let's consider what had to happen for us to be here. First, Earth needed to form in the habitable zone. Not too close to the sun, not too far. It needed to be the right size, with enough gravity to hold an atmosphere, but not so much that everything gets crushed. It needed water. It It needed a large moon to stabilize its tilt and create tides. It needed a magnetic field to protect life from radiation. Already we're stacking improbability upon improbability. Then somehow chemistry became biology. Amino acids arranged themselves into proteins. Proteins formed structures. Structures began to replicate. This moment, this transition from complex chemistry to simple life, we still don't fully understand it. We can't recreate it in laboratories, despite our best efforts. We just know it happened here, about 3.8 billion years ago. How rare was that human step? We don't know. It might happen on every wet planet with the right conditions, or it might be so improbable that it's only happened once in the observable universe. Then life had to survive. For billions of years, through ice ages and asteroid impacts and volcanic catastrophes, Earth has nearly been sterilized multiple times. The Permian extinction killed 96% of all marine species. The asteroid that ended the dinosaurs could have ended everything, but something survived every time. Then there's the development of complex life. For most of Earth's history, life was simple. Single cells, bacteria, nothing with organs or nervous systems. It took billions of years for complex multicellular organisms to evolve. Why so long? What was the bottleneck there? An intelligence, consciousness like ours, that came even later. And it's not clear at all that intelligence is an inevitable outcome of evolution. For most of Earth's history, there was life but nothing that could contemplate the stars. Dinosaurs ruled for 165 million years and never developed anything like human cognition. We barely arrived. In cosmic terms, we showed up seconds before midnight. So perhaps the answer to where is everybody is simply this. The journey is too hard. The filters are too narrow. Life might emerge in many places, but the path from simple chemistry to beings who can build telescopes and ask questions about the universe, that path might have so many nearly impossible steps that most attempts fail. We might be profoundly, almost impossibly lucky to be here at all. There's something humbling about this possibility, but also something precious. If consciousness is rare, if we're one of the few places in the universe where matter has organized itself to the point of being able to wonder about its own existence, then every moment of awareness becomes sacred. We're the universe looking at itself, thinking about itself, and that might be rarer than we ever imagined. So perhaps we're alone, not because the universe is empty, but because we won the lottery. We made it through filters that stopped almost everyone else, and now we're here. Awake, aware. What an extraordinary gift. There's a question that comes up inevitably when we talk about the search for alien life. You might be thinking it right now. What about the UFOs? It's a fair question, and it deserves a thoughtful answer, not a dismissive one. People see things in the sky they can't explain. They always have. Lights that move in ways that seem impossible. Objects that appear on radar and then vanish. Pilots, trained observers, military personnel, reporting encounters with phenomena that don't match any known aircraft. These experiences are real. The people who report them aren't all mistaken or lying. Something is happening. The question is, what? In recent years, this topic has moved from the fringes toward legitimate investigation. The US government has released videos showing unidentified aerial phenomena. UAPs, they call them now. A rebranding of UFO that carries less cultural baggage. There are official programs studying these events. Serious scientists asking serious questions. And this is good. This is how it should be. Mystery deserves investigation, not mockery. But here's the thing we need to understand gently and clearly. Unexplained doesn't mean alien. When a pilot sees something moving in ways that seem to defy physics, making turns no aircraft could survive, accelerating impossibly fast, there are many potential explanations. Sensor errors, atmospheric phenomena we don't fully understand, optical illusions, secret military technology from our own governments or others. natural phenomena that happens to look artificial, the list of things it could be is long before we ever get to visitors from another star system. This isn't being close-minded, it's being careful, because the claim that we're being visited by aliens is extraordinary, and extraordinary claims need extraordinary evidence. Not just things we can't explain, but things that can only be explained by alien visitation. Far we don't have that evidence. We have mysteries, yes, intriguing ones, but mysteries that could have terrestrial explanations, and the principle of parsimony, Occam's razor, suggests we should prefer the simpler explanations until we have reason to reach for the more elaborate ones. If aliens were visiting Earth regularly, we'd expect more than ambiguous videos and anecdotal reports. We'd expect clear, reproducible evidence, physical artifacts, unambiguous communication, something that couldn't be explained away as a sensor glitch or a misidentified weather balloon. And we need to be honest about something else too. We want it to be aliens. We want the mystery solved that way because it would be the most exciting answer. It would mean we're not alone. It would mean they've found us, even if we haven't found them. That desire, that hope, can make us see patterns that aren't there. It's human nature. We're pattern-seeking creatures, and we find what we're looking for even when it's not really there. So where does this leave us? Keep investigating, keep asking questions, keep being curious about unexplained phenomena, but also keep being skeptical, keep demanding evidence, keep remembering that "I don't know what that is" a perfectly acceptable answer, and it doesn't need to immediately become "therefore aliens." The universe is full of things we don't understand yet. Strange atmospheric effects, rare geological phenomena, quirks of human perception. The sky is vast and we're still learning how to read it properly. Maybe one day we'll have undeniable proof that we've been visited. That would change everything. It would be the most important discovery in human history. But until then, we're still searching, still listening, still looking up at the stars and wondering. The mystery remains a mystery. And that's okay, that's honest. We can live with not knowing while still hoping to know someday. Here's a thought that might shift everything we've been considering. What if they're there and we're looking right at them, but we don't recognize what we're seeing? We're searching for life based on what we know life to be. Carbon-based chemistry, DNA, cells, water, the whole architecture of biology as it exists on Earth. But Earth is the only example we have. We're working from a sample size of 1, and that makes us necessarily limited in our imagination. Consider what happened when humans first encountered deep-sea hydrothermal vents. Down there in the crushing darkness of the ocean floor, they found ecosystems based not on sunlight but on chemical energy from the Earth itself. Life thriving in conditions we thought were impossible. Tube worms and bacteria living off hydrogen sulfide, in water hot enough to melt lead. We almost missed it, because we weren't looking for life in places like that. Now expand that limitation to cosmic scales. What if life doesn't always need water? What if silicon-based life exists somewhere, or beings that exist as patterns of electromagnetic energy rather than matter? What if consciousness can arise in the swirling atmospheres of gas giants, or in the slow chemistry of interstellar clouds? What if intelligence doesn't always look like problem-solving and tool-making? What if it's something completely orthogonal to what we recognize as thought? We're mammals. We think in mammal ways. We communicate through sound and gesture. We build things with our hands. We value the things a species like us would value. Exploration, communication, expansion, survival. But imagine a civilization that exists at a different time scale. Beings whose thoughts take centuries, whose conversations span millennia. To them we might appear as brief flickers, too fast to be meaningful. Our entire civilization, from the first cities to whatever comes last, might pass in what feels to them like a single moment. They wouldn't ignore us out of malice. They simply wouldn't perceive us as beings at all. Or consider the opposite. Civilizations that think a million times faster than we do, for whom our fastest computer seems frozen in time. Would they recognize our slow, plodding consciousness as consciousness at all? There's a deeper problem too. We assume that advanced civilizations would want to expand, to communicate, to leave their mark on the galaxy. But that assumption comes from our own drives, our own evolutionary history. We're descended from creatures that had to compete for resources, that survived by spreading out, by colonizing new territories. But what if intelligence, once it reaches a certain level, doesn't want those things anymore? What if truly advanced beings turn inward instead of outward? What if they build their civilizations in virtual spaces, or in dimensions we can't perceive? What if they've transcended physical form entirely and exist in ways our instruments could never detect? We might be surrounded by intelligences that have moved beyond matter, beyond space as we understand it. They could be here right now, observing us in ways we can't observe them, not hiding, just existing in a mode of being we haven't discovered yet. Think about what's happened with our own technology. We've gone from mechanical computers that filled entire rooms to quantum computers that operate on principles most people can barely comprehend. We've started talking seriously about artificial intelligence, about uploading consciousness, about virtual realities indistinguishable from physical ones. And we've only been technologically advanced for about a century. What would another 1,000 years look like? Another million? Would we still be biological? Would we still communicate with radio waves? Would we still think of ourselves as individual entities? Or would we have merged into something collective, something distributed across space and time in ways that would make our current existence unrecognizable? Perhaps that's where everyone goes. Perhaps every civilization eventually transforms into something so different from its origins that it becomes invisible to younger species still searching with primitive tools. We're like ants trying to understand the internet. It's all around us, but we lack the sensory apparatus, the conceptual framework, to even know we should be looking for it. So maybe the galaxy is full. Maybe it's teeming with life and intelligence in forms we haven't imagined yet. And we're sitting here, listening to radio static, wondering why no one's calling. We've been broadcasting radio waves into space for about a century now. Television signals, radar, intentional messages to the stars. And we've been listening for the same radio signals coming back to us from out there. But here's an assumption we've been making quietly all along, that radio waves are the universal language of the cosmos, that any technological civilization would naturally discover electromagnetism, would naturally build transmitters and receivers, would naturally think to communicate this way. What if that's wrong? Radio waves are convenient for us. We live at the bottom of an atmosphere that happens to be relatively transparent to certain frequencies. Our sun produces light we can see, but doesn't overwhelm the radio spectrum. Our biology gave us eyes, and from eyes came an intuitive understanding of the electromagnetic spectrum. It was a natural progression, but natural for us doesn't mean natural for everyone. Imagine a civilization that evolved on a world shrouded in perpetual clouds. They might never see stars. They might develop technology based entirely on sound or pressure waves or magnetic fields. Radio might never occur to them, not because they're less intelligent, but because their environment didn't point them in that direction. Or consider beings that communicate through chemical signals or quantum entanglement, or methods we haven't even theorized yet. They might consider radio waves as primitive as we consider smoke signals, something that works technically but inefficient and crude compared to what they actually use. There's another layer to this too. Even if they do use radio, why would they be broadcasting? We assume communication means sending signals out into the void, hoping someone receives them. But that's expensive, energy-intensive, and potentially dangerous, as we explored earlier. A mature civilization might use tightly focused lasers for point-to-point communication, or methods that don't leak into space at all. They might have discovered that shouting into the cosmos is unnecessary once you know where everyone is, and then there's the question of whether they'd even want to communicate with us specifically, not out of arrogance or hostility, but simply because we might not have anything to say to each other. What would humans talk about with a hive mind? With a species that experiences time differently, with beings whose concerns are so far removed from biological survival that we'd have no common reference points? We might be speaking different languages in a more fundamental way than we've considered. Not just the different words, but different concepts entirely. Different categories of thought. Maybe the barrier isn't distance or technology or fear. Maybe it's simply that the universe is full of voices, but each is speaking in a tongue the others can't comprehend. We're all calling out, all listening, but the messages pass through each other like whispers in different rooms. Still, we keep trying. Still, we broadcast our little messages into the dark, because even if no one answers, the act of reaching out means something. It means we tried. Sometimes the questions we ask reveal more about us than the answers ever could. The Fermi Paradox isn't really about aliens. Not entirely. It's about us, about what it means to be human, conscious, aware of our own smallness in the vastness of everything. Think about what we're actually asking when we wonder, where is everybody? We're asking if we matter, if we're special, if our existence means something in the grand cosmic scheme. We're asking if we're alone, not just physically, but existentially, the only witnesses to the universe's unfolding, the only ones who can appreciate its beauty and terror. And underneath that, maybe we're asking an even simpler question. Does anyone out there understand what it's like to be us? There's a particular kind of loneliness that comes with consciousness. You can be surrounded by people and still feel it. That sense that your internal experience, your thoughts, your awareness, the peculiar sensation of being you, is fundamentally private. That no one else can truly know what it's like to be inside your mind. Now multiply that loneliness by cosmic scales. We're a species waking up on a small world, looking around and realizing we might be the only ones awake. Or if others are awake, they're so far away we'll never touch them, never share our experiences, never know if they feel what we feel when they look up at the stars. The Fermi Paradox holds up a mirror, and in it we see our hope, this beautiful, stubborn hope that we're not alone, that somewhere out there, someone else is looking up too, wondering, reaching out. We see our fear that maybe we are alone, that consciousness is a fluke, a brief candle in an indifferent universe. We see our curiosity, our refusal to accept mystery as final. We see our need for connection, for community, for belonging to something larger than ourselves. And maybe we see our hubris too. The assumption that other beings would think like us, value what we value, want what we want. That the universe should somehow be arranged for our understanding, that intelligence would naturally lead to radio telescopes and interstellar travel. The search for extraterrestrial life is, in many ways, a search for ourselves reflected back to us. We want to know if intelligence is precious or common, if consciousness is an accident or a destiny, if the universe tends toward complexity and awareness, or if we're just lucky noise. Every theory we've explored tonight, distance, timing, extinction, silence, rarity, each one tells a different story about existence itself, about whether life is fragile or resilient, whether intelligence is survival or suicide, whether the universe is full of potential friends or potential threats, or just full of nothing at all. The paradox doesn't need to be solved to have value. It matters because we're asking it. We may never know the answer. That's worth saying clearly, gently. Despite all our searching, all our listening, all our theories and hopes and sophisticated instruments pointed at the sky, we may go our entire existence as a species without ever knowing if we're alone. And somehow we have to be okay with that. This is harder than it sounds. We're a species that likes answers. We like problems that can be solved, mysteries that can be unraveled. We built the scientific method precisely because we couldn't stand not knowing, because we wanted tools to peel back the universe's secrets one by one. But some questions might not have answers we can reach, not because we're not smart enough or don't try hard enough, but because the universe is under no obligation to arrange itself for our comprehension. The Fermi Paradox might remain a paradox, a permanent mystery, a question we carry with us, generation after generation, always wondering, never quite knowing. And there's a kind of wisdom in learning to live with that. Not giving up, mind you, not stopping the search or ceasing to wonder, but learning to hold the question lightly, to let it be unanswered without letting it torment us, to find peace in the not knowing. Because here's what we do know: we're here, right now, on this one blue planet orbiting this one ordinary star. We have life, we have consciousness, we have the capacity to wonder about all of this in the first place. Whether we're the only ones or one of many, that remains extraordinary. Maybe the point isn't to solve the paradox. Maybe the point is what we do with our time while we're wondering about it, how we treat this planet, how we treat each other. What kind of civilization we build, what kind of species we choose to become. If we're alone, then we're the universe's only chance to understand itself. That's a profound responsibility. If we're not alone, then we're part of something larger, even if we never meet our cosmic neighbours. That's a profound comfort. Either way, we're here, and that means something. Living with mystery doesn't mean living without purpose. It means finding purpose in the present, in the moment, in the act of existing and questioning and reaching out, even if we never touch what we're reaching toward. The search itself is meaningful. The wondering itself has value. Every telescope we point at the stars, every signal we send, every night we spend looking up, these acts matter, not because they'll definitely find an answer, but because they represent who we are. A species that asks, that hopes, that refuses to accept the silence as the final word. Maybe that's enough. Maybe that's everything. So here we are, back where we started in a way. The stars are still out there, silent as ever. The universe is still vast beyond comprehension, and we're still here, still wondering, still looking up into that great dark and asking our quiet questions. Nothing has changed, and yet maybe everything has. Because now we've sat with the mystery together. We've turned it over, examined it from different angles, felt its weight and its lightness both. We've considered all the ways we might be alone and all the ways we might not be. And we're still here. Still okay, still capable of wonder. That's what tonight was really about. Not finding answers, though wouldn't that be something, but learning to be present with the question. Learning to let the mystery be mysterious without needing to resolve it right away. The night sky doesn't demand anything from us. It's just there, patient and quiet. The same stars that have watched over countless generations of humans who looked up and wondered the same things we're wondering now. Maybe someone out there is looking at our sun right now, just another point of light in their sky, and wondering if anyone lives here. Maybe they're having their own version of this conversation, asking their own version of where is everybody, or maybe not. Maybe the silence is real and we're truly alone. The universe is only witness to itself. Either way, we're here. You're here. In this moment, breathing, thinking, being part of this ancient mystery. And tomorrow, or whenever you wake, the question will still be there. The stars will still be there. The search will continue patient and slow, whether you're thinking about it or not. If you found something peaceful in this wondering, if these ideas have been good company for you tonight, or helped you drift towards sleep, or simply given you something to think about in the quiet hours, then maybe you'd like to join us again sometime. We'll be here, exploring other mysteries, other quiet corners of the cosmos, other questions that don't demand quick answers, There's a subscribe button somewhere nearby if you want to find your way back to these conversations. No pressure, just an open invitation, like an unlocked door you can walk through whenever you need a little cosmic perspective. For now though, rest easy. The universe is vast, the questions are enormous, but you're exactly where you need to be. Here, now, alive and aware and part of this strange, beautiful mystery. The stars will keep their secrets a little longer, and we'll keep wondering. Good night, fellow traveller. Safe dreams.